That's the reason, yeah, okay.
Math.
I
Imagine
know,
math
yeah,
at your first class.
yes, it sounds wonderful. Now,
Yeah, Red Bull.
So,
it's Christmas.
I have a really bad headache.
on the first day of Christmas, we had maths.
Yes, yes.
The first day of
Please calm yourself down.
Mr. Steven,
What?
we need a warm-up. You can't start like
You've
that.
had enough of a warm-up. Now,
We need eggnog.
yeah, sorry, I left my eggnog carton at home. Okay.
We have to do this.
We're starting now. We're starting now, Nathan. Okay. So we're looking at probability sample spaces. Can we all just calm down now? Can we start, please? No. Right, so we're looking at probability and we're starting with sample spaces. So this isn't something which is difficult, and in fact this is something which you might see in biology even. I don't know if you've done genetics yet, have you? No, it's semester 2. So, Colin will have you constructing sample spaces in genetics. You haven't done genetics yet, so I don't really want to use that as an example, but
We took it in high school.
you took it in high school, so you probably have the basic idea, where you have things like dominant and dominant, dominant recessive, recessive dominant and recessive recessive, and you would like to know,
3 to 1.
yeah, there's probability of the dominant trait being present in this example would be 3/4 as a probability. And this is stuff that you might remember from high school. So this is an example of what's called a sample space. This is something you might be familiar with. No, if not, that's okay. We'll look at more details. So if you want to just write this down as an example, and then we'll give the definition now. Yeah, so the sample space, the definition is now, I know it's not great to use the same word in the definition, but I'm using it differently the second time. So the first time I mentioned space, I'm using it together with sample space, and here I'm using space as a general term, like for example, like set or list or group. So a sample space is a space in which every outcome is given. So in other words, it's just a list of all the outcomes you can have. So a simple way to put it, a list of all outcomes. That's the simplest way to say what a sample space is. It's a list of every outcome. Focus. Okay, can we do some examples and then we have some more definitions?
Yeah.
Yes? Can I scroll down? Yes. What? All okay? Right. So, as an example, we'll say we have a coin, and the coin has two possibilities. It could be heads or it could be tails. So we imagine that we toss it 3 times. Well, let's just do 2 first to make it smaller. And here I want the sample space. So the sample space would be all the possible outcomes. So you could get a heads followed by heads, and then H and T, but then it could be the other way, T and H, and then the final possibility is you get T and T then. So this is our first simple question. The question was give the sample space for this problem. Okay. Can we do another definition?
No. I.
Hurry up. Okay. So the next thing is probability. Would anybody know the definition of probability? How to define it, yeah? Yeah, so it's a likeliness, yeah. And what would be the formula for the definition? Would you know this? Something, something over something, something. Almost. Yeah, so on the top, it's not quite desired outcomes, it's the number of outcomes that you want. Yeah. On the bottom, we have the size of the sample space. So how big it is. In this example, it will be 4. And then here on the top is the size of the desired outcomes, the outcomes that you want. So for this example, suppose I ask you for the probability of 2 heads. Well, the total sample space is how big here? 4. And how many outcomes are outcomes I want? Well, only one. Only this one. Yeah. So this is our next example. Also, you might have noticed that I've written the P slightly differently. This is how you write the P for probability. It's with 2 lines like this. So this means probability of whatever is in the brackets. Okay, so we'll do some more examples.
Wouldn't that count for the tails as well?
What do you mean?
Like if you went to double T.
Yeah, but my question was what's the probability of 2 heads? But the next example, we'll make it a bit different then. Can I do another one?
Yeah.
Probability of the same result each time. So, again, in total there's 4 in total, yeah, sample space. And how many are outcomes we want? 2 this time. So the answer would be half then, 1/2 then. So what you'll probably know is that your probability of your event is always a number bigger than or equal to 0 and less than or equal to 1. Where this one here, when it's 0, means it can never happen, and when it's 1 here, it means it always happens. Yeah, if its probability is 0, it means it can never happen. If the probability is 1, it means it can always happen, or it always happens without exception. It's guaranteed event. Right, and then we'll just do one more. What's the probability of getting a heads and then a tails? So that's a H and a T. What would that be?
1.
1/4 then. Or 0.25 or 25%. You can write the answer anyway. Most commonly would be as a fraction, but in the exam they sometimes want decimal, and in the exam I've never seen them ask for a percentage, but percentage is valid as well here. So I think the best thing to do for this lesson, this worksheet, because they're all simple, short questions, is if we just take turns doing the questions in the worksheet. So I've basically done number 1 here as an example to explain, and we'll take turns of doing them. I'll just put it on the board. Can we scroll down? Yeah. So I'll give you, it should only take you like 1 minute to do. Let's try number 2. Here it is here. Okay, can we see that? I'm going to have to set the projector on here. Come on. If it doesn't open here, you'll have to just look at it on your phone. Come on. No. Okay. You'll have to open it on your phone. So if we can all try number 2, please. Maybe I can open it on my laptop.
We have a quiz time.
Yeah, there we go.
I don't need to.
Resume at fair point.
Number 2 here. Yeah, a fair coin just means it's 50-50 for heads and tails, they're equally likely.
Do we write the question down?
No, it's okay. Just give me the answer.
No. I'm not sure what the question is asking.
Yeah, well, we'll do it now. Can we have a look at it now?
Yeah.
Well, I'll give you a hand. I'll start it for you. First is the sample space. So you're tossing the coin 3 times, yeah? So we have 8 possibilities. Heads, heads, heads. Heads, heads, tails. Heads, tails. Heads. Heads, tails. Tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. So these are the 8 possibilities, yeah? No, not yet. that's something that we'll have a look at in a different lesson. But basically, in my head, what I did was 2 power 3. Yeah, but it's something we'll look at later, actually. There's 8 possibilities here. Right, so what's the first question? Let me just get it here. What is the probability of 3 heads? So what's that one? 1 over 8. What's the probability of exactly 2 heads? Now, just be careful here. We have to highlight how many that are. So that's this one, this one, this one. Just the 3 of them, isn't it? So it's 3 over 8. And the last one is a little bit different. It says the probability of at least 2 heads. So that's nearly the same, except it includes one more. Which one? The first one has at least 2 in as well. So this is 4 over 8, which is 1 over 2. Yeah. Yeah, which is the case in C. And D was at least 2, which means this one, this one, this one, and this one here has at least 2 in it. So this was for C, C, and C, but this one was for C and D. Oh, sorry, huh? Sorry, only for D, thank you.
I just didn't know how to calculate the first part, you know?
This is for C and D, C and D, C and D, but this one's only for D. Yeah.
Like, I didn't know how to write all that.
And you just need to practice.
Me neither.
Huh?
Me neither.
First question was what is the sample space, so you need to write it out, yeah.
Yeah, but how, like, I wrote it as, like, 6 options. Like,
So you missed 2 of them.
yeah.
You notice how I stacked them 4 and 4, so all of these started with heads and then all of these started with tails.
Okay.
It just made it a little bit easier to keep track of them.
Okay.
Okay, let's have a look at the next one. So if you can try number 3, please. And I should say that this question is the type that I've seen on biology exams before, like the entrance test.
Oh, you mean for,
Yeah, the all those other European schools. They have a maths exam, and one of the questions I remember would be a type of question like number 3. So if you can try number 3, please, now. It's a little bit shorter.
wow, she gives both the form momentum impact of my. Oh, I thought
I guess that a woman gives birth 4 times to 4 children. I just wanted to make it clear that there's no twins or triplets here.
One child individually.
Yeah.
so not quadruple.
No. Because the reason is, if she gives birth to twins, I think it makes it slightly more likely that the genders are the same. Because if you give birth once and then twice, the probability of boy and girl is 50-50. The first birth doesn't influence the second birth. But in the case of twins, this is not the case, because you've got a chance of having identical twins, which would make the genders the same. So in other words, they're no longer, they influence each other. So I just wanted to make it clear here, there's 4 births, and each time there's 1 birth, making a total of 4 children.
Yeah.
Okay. So try number 3.
3. You have to add something.
Boy, girl.
Each child has 50-50 chance.
Yeah. In other words, Abdullah, it's just like the coin flip. They're equally likely male or female.
Okay.
The first coin flip or the second coin flip?
What?
I mean, the non.
No, you're thinking about this too much and complicating it. The chances of the child being born male or female is like a coin
8
flip.
options, right?
Huh?
8 options.
Yes, 8 options here. No, sorry, there's 16 options. 16, yeah. 16.
Boy, 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 boy.
Boy. Okay.
Okay, do we have this one? Yes.
Two boys and two girls.
Okay, let's have a look here. Well, I'll help you out anyways. We'll start by writing down the sample space here. This is for number 3, isn't it? So, you can have male, 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 and male. Male, 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 and female. Male, male, female, and male. Male, male, female, and female. Male, female, male, and male. Male, female, male, female, male, female, female, male, male, female, 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 and then I have to do this all again, but only female in the front. So.
Oh.
Yeah. Although it won't be this big in the exam. I think the maximum would be 3. Although, I know, I might have seen 4 once. So this would be the worst case for the exam. Female, male, female, male, female,
Is
male.
it more worse than that?
No. Female, female, male, male, female, female, male, female, 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 male, female, 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 female. Right, so the question is, what is the probability of 2 boys and 2 girls? So let's highlight those. No, 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 yes. No, yes, yes, no, no, yes. What was this, man? Yes, no, yes, no, no, no. 1, 2, 3, 4, 5, 6. Was it? So the probability is 6 over 16. 3 over 8.
Alright, is it okay to read the 6 seconds to write it down? Sorry.
Yeah, right down, yeah. Now I must have miscounted something here. I should only have 5 over 16.
Yes.
Which one did I... Hang on, let's just double check.
You said two players and two.
Oh, the answer at the back's wrong. This is right. Okay. Yes, indeed.
What's that?
I need more space.
Yeah, I don't see anything I've missed here. So it is 3 over 8 then. Yeah. Okay, write this one down then. Okay.
Almost.
Can I scroll down a bit? Okay guys, I need to push on, so if you didn't get this, you'll just have to get it later then, okay? I wanted to go down and give you another formula before we continue. So there's a useful formula here that can sometimes help make the questions go a bit faster. It's when you have something like this. If you want the probability of an event, let's just call it E, whatever E is. In this case it was 2 boys and 2 girls. That's the exact same as doing 1 minus the probability of not getting E. So for example, if I was to say what is the probability of not getting 2 boys and 2 girls, that would be 1 minus 3 over 8. Sometimes it's useful to reverse the question like this. So if I did ask you that here, you would do it that way. Let's have a look at number 4 here. Now, if you look at number 4, you realize that you could use your answer from number 3 to help you, because in number 4 it says a coin is tossed 4 times. What's the sample space? Well, that's the same as the last one, isn't it? Except male could be heads and female could be tails, for example. So if I said, what is the probability of a different result on each toss? So what that means is probability that they're not all the same. That's what I mean by a different result each time. No? Wait, hang on, let me read the English again very carefully. What is the probability of a different result on each toss? Sorry, so that would be heads, tails, or tails, heads, tails, heads. So, how many possibilities is that? 2. And how many have I got altogether? Yeah. 2 over 16, 1 over 8. Okay, everybody try number 5. That's a little bit different now. Can I go to number? Let's try number 5 here. Just a sec. Let me fix that mistake. Okay, number 5. You can try that.
This one from here. I think I got it. The mistake?
There's 3 diagrams.
No, we haven't done that yet, so do it the same way. The answer here should have been 6 over 16, wasn't it?
Number 5?
Yes.
It's the 3 options.
Red, green, blue.
Red.
Finishing.
Red.
Fishing on a red would be an interesting question, but it's finishing on a red.
It's like red, 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 and red, red, two, red.
No, because it's taken out and it's not put back in again. So you cancel the probability of taking, like, if you take red first, you can't take red again.
Hmm.
Red, red, blue,
So basically we can't have the same time. Try this. Red, green, blue, green, red, blue, green,
Finish.
red,
Let's have a look at number 5 now. So number 5 says a bag contains one red, one green and one blue ball. A ball is selected at random 3 times without replacement. This means the ball is not put back into the bag after you take it out. So what is the sample space? So we could first pull out red and then we could pull out green and then we could pull out blue. Or we could have red, blue and green, green, red and blue, green, blue and red, blue, red, green and blue, green, red. So the question is, what is the probability that you finish on a red? So that is this one and this one.
one.
Oh, sorry. I was 6. This one and this one. So that's 2 over 6, which is 1 over 3. Okay. Got that? Now, can you try number 6? And number 6 is nearly the same, except there's one difference here. It says with replacement. So number 6, the ball is put back into the bag after you pick it out. So for example, it's now possible to get red, red and red.
Could you,
Abdullah!
Yes?
Worked.
gosh, green, red, 1. Okay, 2, 4, 3, 4, and we only have 2 bags. I'm gonna try myself.
Okay, have we got this one finished now? 1 more minute. Yeah.
37.
Wait, what?
1, 2, 3.
I'm not doing it.
4, 5, 6, 7, 8, 9.
I stopped guessing.
Alright, let's have a look. So, now we can replace each time. So, we can have red, 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 and then we'll just have here red, red, green, red, red, blue, red, green, red, red, green, green, red, green, blue, red, blue, red, guys, red, blue, green, red, huh? No, I've done something. Red, 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 green, 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 blue, 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 red, green, blue, red, green, blue, red, green, blue. Yeah. So notice how I'm trying to stack them up to keep track of what I'm doing. So here, they all start with red. Can you see that? And then here, these are red, 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 green, 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 and blue, blue, blue. And then the last three go red, green, blue, red, green, blue, red, green, blue. I repeat this again, but there's only one difference. What do I make in my second column? I should probably start with green. But the next two are the same. So for example, this would be green, red, red, and this would be green, red, green. And then the last column would be blue. Yes? Now, did you see? Now, let's imagine that when I say red, 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 it means this is the last one, this is the second last one, and this is the first one. So, first I got a red, then I got a red, and then I got a red. What would be this one here? First I got a I didn't write here. Red, then I got a red, and then I finish on a green. And for example, what about this one? First I got a red, then green, and then blue. And my question is, what is the probability that I finish on a red? Well, how many of those are? 9 of them. And how many altogether? 27. 1 over 3. Which kind of makes sense if you think about it, because by the time you get to the last ball, there's still 3 in the bag, and only 1 of the 3 is red. Yes? Okay, there's still a couple more I want you to do. I want you to do 7, and then we'll finish on 8. I need you to do 8 because I want you to finish these at home, and 8's a bit different. So 7. Yeah, I know.
Well, we can do a tutorial.
No, we're doing it now.
At home?
No, I meant the rest of it.
Do 7 now.
Okay.
So it's a lot like the red, green, blue. You have 6 possibilities.
That the will stand.
There's a typo, I'm sure.
They will stand. So it's not short.
No, hang on. You know that's ridiculous. Think about it for a second. You have 3 children, tall, medium and short.
Oh, okay.
How could they stand in line so that the short one and short one and short one? Unless we have a cloning machine.
You know?
Okay, let's have a look here. This is number 7. How many possibilities? 6. So you can have tall, medium, short, tall, short, medium, medium, tall, short, medium, short, tall, short, medium, tall, short, tall, medium. 6, and how many of them are we interested in here?
1.
No.
No, 2.
2.
SMT and then
Tall, medium, short, or short, medium, tall.
But the question is from shortest to tallest.
Yeah? I did that on purpose. But I never said the tallest person starts the line and the shortest person ends the line.
So that's 4. That's 4.
But if students are, imagine I asked, okay, so I asked, wait. If I asked the students, 3 students to stand at the back of the room in a line from shortest to tallest, as I look at them standing on the back wall, I could see small, medium or tall, or they might have stood the other way. Yeah. It's only because in English we write from left to right, so we think it should be small, medium, large. But if they were 3 Arabic students, they might reverse the order, because they write from right to left. You know what I'm talking about, right?
This we didn't take your numbers.
Yes, this is from smallest to tallest. These are in order, true? And from tallest to smallest, these are in order as well. They're both in order.
Yeah, they
Yeah. The only difference is here I'm writing from left to right, and here from right to left.
Why do you put the medium then?
Because I'm writing from left to right, so that's what I'm used to. Alright, fine. Better?
Yeah.
Okay, great.
What about the medium?
Yeah, that's better.
They're still in order, you know.
Nice.
Now you see the word, I might have had to add in more words to specify one of the 2. So like, I could have added in things like ascending or descending. No, but high order still doesn't tell me if I should start with the smallest and then move to the right to make taller, or the other way around.
if you write
What?
just height order, it could either be start with the shortest and with the tallest, or start with the tallest and with the shortest.
3 children are standing in a line. What is the probability that they will stand in order of their height, shortest to tallest?
Oh.
There's
You got the shortest and the tallest.
goodness sake, all right. Fine.
1.
Now, is that better?
Yeah.
Yeah, great. Alright, we'll just finish on number 8 then. If you can just do number 8 quickly. Do you know what? I'll do number 8. Just read it with me. 2 dice are rolled. What is the sample space? So you roll 2 dice. Not as many as 64. So when you roll 2 dice, what's the smallest possibility you could get? A 1 and a 1. And then a 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6. 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. What the heck? Sorry, my brain stopped working for a second there.
Yeah.
Yes, indeed. For some of us, it's stuck permanently and not working. Ooh! I said for some, I didn't say who.
Okay, thanks. I'm
It
trying
might
to
be
find
you.
Right. Are you writing this down? Come on.
I thought we were doing it.
the probability of me understanding
Almost great stuff.
the probability of me understanding the system, probability of me understanding the plan.
Okay, so the reason you need to draw this is because you need to use this for questions number 9, 10, 11 and 12. So in 9, 10, 11 and 12 it all uses this sample space. So we'll just do number 9. Number 9 is, what is the probability that when you roll a pair of dice, the two numbers are the same? So how many of those outcomes, the diagonal, yeah, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. So how many possibilities is that? 6, and how many altogether?
1, 2, 3.
36. 1 over 6 then. And then in number 9 is, number 10 is, what is the probability that the total is 7? Now, how many results add 7? So what's the first one? 6 and 1, and then
The other diagonal.
5 and 2, 4 and 3, 3 and 4, 5 and 2, and 6 and 1, or
So do you count the numbers? Because they repeat.
yeah, but this is everything, isn't it? Yeah, it's a diagonal again. So in this case, how many? In this case, it's also 6. And then lastly, we'll just do one more. What's the probability that the total will be 10? 5 and 5. What else? 6 and 4, and then 4 and 6. Where's 4? There it is. So that one would be 3 over 36, which is 1 over 12 for that one.
So are you going to teach us how to calculate the sample space properly?
There's nothing to teach. It's making a list of possibilities.
So just
My
practice.
recommendation is you try to group them like I did in the last one. I mean, here I try to do things like start with the same one in 3 different columns, you know what I mean?
Okay.
We've gotten up to question 11. There's 15 questions altogether, so 12, 13, 14 and 15, you should finish that at home, okay?
Yeah.
So those 12, 13, 14, 15 for at home.
What are we going to do today in the tutorial?
The tutorial will probably be a bit of calculus, like maybe some more area questions, whatever people need to see.
I thought we should, because it's we have a coursework due on Monday.
Yeah, we can talk about coursework and we can even talk about active listening too.
Yeah.